Hi everyone, I'm delighted to welcome you to this video on arithmetic functions. And this is Dr. D.Amsaveni, Associate Professor, PG and Research Department of Mathematics, Sri Sharada College for Women, Salem. In this video, we will dive into the fascinating world of arithmetic functions and we see the sum of their properties also. An arithmetic function f is one whose domain is the positive integers and whose range is a subset of real or complex numbers. Let's define the arithmetic functions tau of n and sigma of n. For each positive integer n, we make the following definitions. Tau of n is the number of positive divisors of n. Sigma n is the sum of the positive divisors of n. Sigma k of n is the sum of the kth power of positive divisors of n. Say for example, if we take n is equal to 6. Number of positive divisors of 6 are 1, 2, 3 and 6. That is D is 1, 2, 3, 6. Now tau of n is the number of positive divisors of n. So tau of n counts the positive divisors of n. Therefore, there are 4 positive integers in the set D. Therefore, tau of 6 is equal to 4. Sigma of n is equal to, sigma n is nothing but sum of the positive divisors of n. So we have to add these divisors, that is 1 plus 2 plus 3 plus 6, which is 12. Similarly, we can find tau of n and sigma n for some positive integers. If we take n is equal to 1, the divisor is 1. D is 1. Tau of 1, the number of positive divisors of 1, that is 1. Sigma 1, which is the sum of the positive divisors of n, that is also 1. If we take n is equal to 2, the divisors of 2 are 1 and 2. Tau of 2 is 2. Number of divisors, sigma of 2, sum of the divisors 1 plus 2, that is 3. If n is equal to 3, number of divisors, so what are the divisors of 3? It is 1 and 3. Tau of 3 is 2. Sigma of 2 is 1 plus 3, that is 4, the sum of the divisors. If n is equal to 4, D is 1, 2, 4. The divisors of 4 are 1, 2, 4. Tau of 4 is 4 counts the positive divisors of 4, 1, 2, 3. Sigma of 4 is the sum of the positive divisors of 4. 1 plus 2 plus 4, so which will give 7. Suppose n is equal to 5. D is 1 and 5. Then tau of 5 is number of positive divisors, which is 2. sigma of 5, sum of the positive divisors 1 and 5. So 1 plus 5, that is 6. So it is clear that tau of n is equal to 2 if n is prime. We can see that from the above example, for the prime numbers, the divisors are 1 and the number itself. 1 and number itself. If n is prime, the divisors of the prime numbers are 1 and the number itself. So we get tau of n, the number of divisors of the prime number is 2. In the same way, always sigma n is equal to n plus 1 if n is prime. The prime number and 1. The prime number and 1. 1 always will be the divisor of the prime number. For example, if I take n is equal to 3, sigma of 3 is equal to 1 plus 3, which is 4. If I take n is equal to 5, sigma of 5 is equal to 1 plus 5. Prime number plus 1. So that's why sigma n is equal to n plus 1 if n is prime. Now we can use the symbols summation f of d for tau of n and product f of d divides n, here also d divides n, for sigma of n. Since tau of n counts the positive divisors, tau of n is equal to summation 1 d divides n. We count the divisors of n. So if there exists a divisor of n, the count will be 1 and sum it. Say for example, n is equal to 6. The divisors of 6 are 1, 2, 3, 6. Then tau of n is equal to summation 1 d divides n, which is equal to, if 1 divides the n, that is 6, then the count will be 1. If 2 divides 6, then the count will be 1. If 3 divides 6, then the count will be 1. So likewise, summation 1 d divides n will be 1 plus 1 plus 1 plus 1. So this one, if there exists a divisor for 6, which is equal to 4. Okay, so if we want to find sigma n, sigma n is equal to sigma of 6, which is equal to summation d divides 6 d. Therefore, what are the divisors for 6? 1, 2, 3 and 6. 1 plus 2 plus 3 plus 6, which is equal to 12. If it is small positive integers, then we can compute tau of n and sigma n in easy manner. If we have large number, it is difficult to find all the divisors of D. If we want to find tau of n and sigma n for the large number, first we write the positive integers into prime factorization. For example, n is equal to 120. So we are writing this 120 in the prime factorization. That is 120 is equal to 2 cube into 3 power 1 into 5 power 1. We want to find the divisors of 120. The divisor D also can be expressed in the prime factorization. That is D is equal to 2 power alpha 1, 3 power alpha 2, 5 power alpha 3, but with the condition that 0 less than or equal to alpha 1 less than or equal to 3, 0 less than or equal to alpha 2 less than or equal to 1, 0 less than or equal to alpha 3 less than or equal to 1. 3 is the power of the first prime number. The power of the first prime number. Maximum power of 2 is 3. This 1 is the power of the next prime number. Here also the maximum power of 3 is 1. And this is the power of 5. Maximum power of 5 is 1. Now, considering the different choices of D, then since alpha 1, alpha 2, alpha 3 taking least value 0, and we take alpha 1, alpha 2, alpha 3, 0. So D1, we are going to find the different choices of D. So D1 is equal to 2 power 0, 3 power 0, 5 power 0, which is equal to 1. D2 is equal to 2 power 1, 3 power 0, 5 power 0 is equal to 2. Suppose if you take alpha 1 is equal to 1, alpha 2 is equal to 0, alpha 3 is equal to 0, we will get 2. And D3 is equal to 2 power 0, 3 power 1, 5 power 0, which is equal to 3. D4 is equal to 2 square, 3 power 0, 5 power 0, which is equal to 4. D5 is equal to 2 power 0, 3 power 0, 5 to the power 1, which is equal to 6. 5. D6 is equal to 2 power 1, 3 power 1, 5 power 0 is equal to 6. D7 is equal to 2 power 3, 3 power 0, 5 power 0, which is equal to 8. D8 is equal to 2 power 2 to the power 2, 3 to the power 1, 5 to the power 0, that is 12. D9 is equal to 2 power 0, 3 power 1, 5 power 1, which is 15. D10, which is 2 power 2 squared, 3 power to the power 0, 5 to the power 1, which is 20. D11, 2 power 3, 3 to the power 1, 5 to the power 0, 24. D12 is equal to 2 to the power 1, 3 to the power 1, 5 to the power 1, that is 30. D13 is equal to 2 cube 3 power to the power 0, 5 to the power 1, which is 40. D14 is equal to 2 to the power 2, 3 to the power 1 into 5 to the power 1, which is 60. D15 is equal to 2 power 3, 3 to the power 1, 5 to the power 1, and this will give 120. Here we find all the choices of D. Now, hence the number of positive divisors of 120 is 15. Count these all possible choices of D, then we get 15. So this is the number of possible divisors of 120. So which is 15. So that is tau of 120 is equal to 15. And D is equal to D is equal to D is equal to D1, D2, etc. That is 1, 2, 3, 4, 5, 6, 8, 12, 15, 20, 24, 30, 40, 60, 120. So these are all the divisors of 120. It is clear that if n is the prime factorization, which is prime factorization of n, which is greater than 1, then the positive divisors d of n are also will be in the prime factorization. In general, say if n is equal to p1 to the power alpha 1, p2 to the power alpha 2, etc., pr to the power alpha r is the prime factorization, then the divisor d, then the divisor d of n takes the form d is equal to p1 to the power a1 up to pr to the power ar, 0 less than or equal to ai less than or equal to alpha I, 1 less than or equal to I less than or equal to r. And sigma k of n. So already we have discussed sigma k of n is the sum of the kth power of the positive divisors of n. Now sigma k of n is the sum of the kth powers of the positive divisors. So if we take n is equal to 6, then sigma k of n is equal to, if k is equal to, in k can be any real number, positive, negative or 0. So if we consider, if we take k is equal to 2, then sigma 2 of 6 is equal to 1 square plus 2 square. So the divisors of 6 are 1, 2, 3, 6. So 2 square plus 3 square plus 6 square, which is equal to 50. The functions tau of n and sigma n are the special case of sigma k of n. If k is equal to 0, then sigma 0 of n is equal to tau of n. If k is equal to 1, sigma 1 of n is equal to sigma n. So if we consider the previous example, that is, if we take n is equal to 6, sigma naught of 6 is equal to 1 power 0. By the definition, it is a kth power of sum of the kth power of positive divisors of n. So 1 power 0, 2 power 0, plus 3 to the power 0, plus 6 to the power 0. So which is equal to 1 plus 1 plus 1, that is 4. Sigma 1 of 6. Sigma 1 of 6 is 1 power 1 plus 2 power 1 plus 3 power 1 plus 6 power 1, which is equal to 12. Is equal to 12. So that is, from the previous example, this is tau of n, and this is sigma of n. So let us see this property. So if n is in the prime factorization, that is p1 to the power alpha 1, p2 to the power alpha 2 up to pr to the power alpha r, then tau of n is equal to alpha 1 plus 1, alpha 2 plus 1, etc. alpha r plus 1. Also, tau of 1 is equal to 1. Now, to see the proof, let n is equal to p1 to the power alpha 1, p2 to the power alpha 2, etc. up to pr to the power alpha r. A positive integer, d divides n if and only if d, the divisor d can be expressed as a product of prime factors, that is p1 to the power f1, p2 to the power f2, etc. pr to the power fr, with 0 less than or equal to fi less than or equal to alpha I, for I is equal to 1, 2, 3, etc. r. So p1, p2, etc. pr are the primes, while e1, e2 up to alpha 1, alpha 2 up to alpha r, the positive integers. We know that if P is a prime and alpha greater than or equal to 1, an integer, then all positive divisors of P power alpha are 1, P squared up to P power alpha, which are alpha times P plus this one in number. Here 1 is also the divisor of P power alpha. Hence, tau of P alpha, which is nothing but the number of positive divisors of P to the power alpha, which is equal to, from this is alpha plus 1. For example, if we consider the divisors of 2 power 5, it can be expressed as a product of prime numbers, prime powers, that is 1. 1 is also the divisor of 2 power 5. 1, 2, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. So these are the divisors of 2 power 5. Therefore, tau of 2 power 5 is equal to 5 times 1, 2 power 1, 2 power 2, 2 power 3. So this is 5 plus 1, which is equal to 6. Therefore, likewise, the positive divisors of P1 to the power alpha 1 is alpha 1 plus 1, P2 to the power alpha 2. The number of positive divisors of P2 to the power alpha 2 is alpha 2 plus 1 up to the number of positive divisors of PR to the power alpha R is alpha R plus 1 tau of n. So therefore, we have proved if n is equal to P1 to the power alpha 1 up to PR to the power alpha R, then we get tau of n is equal to alpha 1 plus 1, alpha 2 plus 1, etc. alpha R plus 1. Also, tau of 1. Tau of 1 is equal to 1. It is clear that, so this is n is equal to 1. If n is equal to 1, so always tau of n, the number of positive divisors of 1 is 1. Hence, we have proved this result.